Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
And we will see how Gradle helps us, right? So, because we have already talked about Maven, you would already know what is a build system. Yeah. So, a build system is a automation solution which enables you to perform your project management tasks or project development tasks in a predefined manner with a lot of automation provided to you for performing like compilation or testing or packaging, deploying and executing your project, right? So if you use, for example, Maven, or if you use Gradle or any other build system like CMake or Make for C files and for ANT for general purpose, builds, you can define some automation for compilation of your project, yeah, or testing of your project, or even packaging and deployment of your project, right? So why do we need this? Why do we need this automation? Well, this is required so that your developers, your team, you yourself do not have to manage all the complications which are part of these activities. For example, if you want to compile a project, you may want to take care of the dependencies, right? You may want to take care of the outputs, right? And you want to take care of defining the exact steps that you want to execute when you are running the compilation. This is just an example, right? Same problems would go for tests. Maybe you want to uh, get rid of managing a test framework yourself and you want to hand it over to build system and things like that. That's what build system is required. And I guess you guys are already aware of it because you have worked with Maven, right? So Maven is a very popular build system which is used for mostly Java based project, right? So if you use Maven, it provides you a lot of automation. For example, it provides you a standard convention, right? Where the phases and life cycles are already defined, right? So you have Maven validate, Maven verify, Maven compile, Maven test, Maven package, then Maven deploy, Maven install. Yeah, all those phases are already defined, which provides you a bit of a out of the box experience when you use Maven, right? So you can create a Maven project and immediately say Maven compile, and something will happen. Maven will compile. Now, to achieve this, Maven also defines standard convention, right? For example, your directory structure, right? So your source code should always stay in src/main/java. This is a folder where your source code should stay for your application. If you are using Maven, right, then your test code should be src test/java, right? So you have some standard predefined directory structure which has to be honored for Maven to work properly, right? So Although Maven is very powerful, it gives you a lot of out of the box automation, and it is also configurable to certain extent. You can also increase the functionality of Maven by using Maven plugins and dependencies, right? Dependencies. But there's a little bit of a problem with Maven, that it does not give you enough freedom to configure your project in different ways, right? If you want to configure a project according to Maven's convention, then you are good to go. But if you have maybe a different directory structure, or if you have a different set of instructions for compilation, then you may face a bit of a challenge in adopting Maven, right? So configuration um, is placed below convention. So convention is given highest priority. So your directory structure, your default phases, your plugins and dependencies, all these are conventions which enable your project to be managed by Maven, right? So Maven emphasizes on convention over configuration. Now this is a problem which is not faced by another build system called Ant, right? I'm not sure if you guys have heard of Ant. Ant stands for another neat toolkit. Another neat toolkit, right? Now Ant is also a build system. It's a general purpose build system. Maven is mostly for Java. I think it is exclusively for Java. And Ant is a general purpose build system. You can use it for C or Java or Python, or any kind of projects, right? And here, I mean, Ant is like an open box. You can do whatever you want there, right? You can define your own tasks, right? You can perform as much as customization as you want, right? You can have some sort of dependencies as well. And all these configurations are written in an XML file called build.xml. Okay, so your Maven project also can be managed using an XML file called pom.xml, right? Can anybody give me the expansion of POM? What does POM mean?
It's the project object model.
Yes, project object model, right? Project object model. So project object model contains the dependencies and project configuration details, right? And ANT also has build.xml. Now the build.xml has to be is a high maintenance XML here. You can define whatever tasks you want to execute, what happens when you compile, what happens when you test, what happens when you deploy. All the steps are defined by the build manager or the development team. In Maven, on the other hand, everything is built in. Your compilation is built in, right? You don't have to define what happens in compilation when you use pom.xml. It is built into Maven. But in Ant, you have to define everything. So here in Ant, although it is highly customizable, and equally powerful as Maven, but there is still a cost involved, which is high maintenance, right? This is a high maintenance way of managing your project. Now, advantages of Maven is convention, right? So you got your default conventions here, which enable your project to be immediately manageable with Maven, but very less configuration. So the configurability is very less, right? So for example, you have to follow this directory structure. Now in Ant, it is high maintenance, right? Because you have to customize or define your build steps on your own, but it is highly customizable. Again, The same thing has pros and cons, right? Highly customizable, very good, but it becomes high maintenance. Now, people wanted the different solution, which could give them the default benefits that come with Maven and also give them the benefits of Ant, which gives them customizability. So something which the teams can immediately start to use, but also can customize. That's when that's where Gradle comes in. Right? I'm sorry I have to change the colors many times. It may be distracting, but so that's when Gradle comes in. Yeah. So Gradle brings some default implementations, right? Plus, if you don't want to use them or you want to use them, whatever, you can have your own customizations, right? So default implementation will give you default build targets. For example, if you want to compile something, you will get a target called compile. But if you want to define your own compilation steps, you can define your own tasks, right? So that's how Gradle was designed, and it became so popular that it became the default build system for Android. And this is a huge win for Gradle because Android is, I think, one of the most complicated software projects after Linux, right? So if that bigger project can be managed by Gradle and can be recommended by Android team, then definitely it has something going on in its favor, right? So it's a default build system for Android. Now, Gradle works with any programming language. That is one of the advantages here. Maven exclusively works with Java, right? And works with any programming language. Gradle also works with any programming language, right? So you can use Gradle for Java or C, CXX, or manage Swift or Groovy based projects or whatever. Whatever your project flavor is, you can use Gradle, right? So there is an advantage in learning Gradle as well, right? So you can use Gradle in any of the project management. Doesn't matter where you work or which project you work, you can always use Gradle. Yeah. And one of the things that Gradle has done is that it is designed so that you can reuse whatever resources you could use in Maven. So in Maven, you can use repositories, right, for plugin resolution. So you have your plugins and dependencies, right? The same plugins and dependencies which you used in Maven, for example, your JUnit dependency, right? JUnit plugin or SonarQube plugin. The same can be used in Maven as well. So you can reuse whatever was in Maven in Gradle, right? So you can use Maven repositories, Maven based repositories, or if there are Java repositories, other Java repositories, for example, JCenter, or you can also use local repositories, right? So it tries to reuse whatever you have, whatever Maven has built upon, it reuses that. Okay. Now some advantages here for Gradle. What are some advantages? First is speed, right? Gradle is extremely fast, right? Compared to Maven, it is extremely fast because it does incremental builds. That means it will, if you run, for example, Gradle compile, and then make changes. If you have a huge project, let's say the project has 10 Java files, and if you say Gradle compile, it will compile your project. But then you change one file out of the 10 files and you say Gradle compile again, it will just work on that one file. The remaining files which are not touched will not be worked upon by Gradle. So it will work only on the incremental build. It will compile, or it will deal with the files which are changed, and only them, not all of them, right? By default. Then it uses a build cache. This is very important, right? So maybe I'll spend some time here itself. So let's say you have a Git repository, right? Your project in your Git repository, and there is a developer A which has downloaded the project, and he or she does a compilation, right? The developer A downloaded the project and does the compilation. Now what Gradle will do is, whatever artifacts are generated for the compilation, right? Intermediary binary files, information about what files were compiled, what is their timestamp, everything Gradle will publish to a cache. Okay, cache is a centralized place to store your build information. Now, if the same code base is downloaded by developer B, right? Let's say developer B downloads this and performs compilation again, right? So before performing the compilation, when Gradle compile or whatever command is given, the Gradle will talk to the build cache. Gradle will communicate with the build cache, and it will see, does any existing information about the files which are being compiled exist in the cache, right? And surprisingly, it will find that exact files which are downloaded by dev B have been compiled already from developer A. So what Gradle will do is, it will bring out all the required artifacts from cache and give it to developer B, right? So it will avoid running a duplicate compilation. So you have your build cache, which is huge, which has huge impact on the performance of builds, right? So build cache is a very unique concept, and it is used extensively, right, by many teams. So that is how they can manage big projects like Android. They have build cache, and that can be reused by multiple teams. Okay, so this is one advantage. Another advantage is portability, right? So when you have a Gradle based project and you want to, let's say, run it on Jenkins. You have not learned Jenkins, I think, till now. But let's say you want to run it on a remote system. There is a remote machine and you want to run a Gradle build there, right? Now, to work with Gradle, you need to install Gradle, right? You need to install Gradle. But Gradle also provides a wrapper which you can check into your source code repository, which enables you to run Gradle build without even installing it. So no need to worry about installation of your Gradle binary. It can run anywhere then, right? So portability is high, right? So this is one advantage. Another advantage is migration from existing projects. So you can easily migrate from Ant based projects or Maven based projects. So there are tools which allow you to migrate from a existing Maven project into Gradle. So all the functionalities which you have defined in Maven will automatically be imported in Gradle. So if you want to migrate, you can from any other build system, right? Now, another advantage here is to write your build configurations. Right? In Maven, you use pom.xml, right, which is generated by default, but it is XML. And similarly, here it is build.xml, right? These are just configuration file. static data files which contain some information about what to do and what not to do. In Gradle, these build files are written in a programming language, right? So Gradle supports two languages, Groovy, two languages for writing its build configuration, not managing the compilation and all, writing its build configuration. So you can write the build configuration, I would say build config, in either Groovy or Kotlin. There is a language called Kotlin. So build configuration is written in Groovy or in Kotlin, right? And this, because this is also a programming language, you can write intelligent build scripts, right, which have their own intelligence. You can execute them as a separate entity itself, right? Whereas in Java and in Maven and ANT, you have XML files which are just data files. They don't have any intelligence in them. All right. So this is why Gradle has become much famous and much more widely accepted because of all the advantages that it brings here. Any questions on this slide? Is build cache on Git? So you guys can unmute yourself as well, right? But I got a question. Is build cache on Git? From there the other developers get the cache? Is it, how is cache accessed? We will talk about this. If time permits, we will talk about this. Right? Right now I'm just sharing the concept.
So far, so good, Amit. We can proceed.
All right, good. Okay. Just give me one sec. Okay, so let's move on to how do we use Gradle. So let's install Gradle then, right? So this is my Windows machine. You can install Gradle on Windows or Linux or Mac, wherever you want, right? So if I just go to my command line and I type Gradle, so it should print some default output, and that means Gradle is already installed, right? So Gradle 6.0.1 is already installed, right? And if I say Gradle version, it is 6.0.1, right? The latest Gradle version is 7, Gradle 7. Right? So this is Gradle. Now, how to install it? I have already done it on my system. How do we install it? Simple Gradle installation. Let's search for that. And the first page is Gradle installation, right? So what you can do is you can go for installing manually. And here you have installation notes. So you can go to the download page and you can see 7.1.1 is the latest installer, right? One problem with Gradle, and I wouldn't say it's a problem, but it's something that you should really know, is that it is very active in development, right? You can see May 7th they released 6.9, and then May 10th they released 7.0.1, and then May 14 702, and now in July 2nd we have 7.1.1. So we should always ensure that we are using the correct version of Gradle, because if you developed something, if you developed a project based on 671 and then you give the project to someone and then they start using Gradle 711, then there may be incompatibilities, right? So always try to use the any version that you are using, stick with that. Okay, so let's go to binary release, and it is going to download the zip file for us. So it downloads the zip file for us, right? And I don't know if I lost it here. Yep, so you can see Gradle 711 and everything is here, right? All the binaries and everything is here. Let's unzip it. I will say right click, 7-zip, and extract to Gradle 711. Gradle 711 is extracted, right? Now let's go to the installation documentation again. So downloaded binaries, right? The next step, extract it somewhere. So we have already extracted it to my downloads folder. So if I go to my downloads folder here, and here is my Gradle 711, right? Here is the binary downloaded. Okay, what's the next step now? The next step is to configure the paths here. So we need to add the bin folder of our installation or of our extraction to the environment variables, to the path variable. So it doesn't matter if you are on Linux or if you're on Windows, you have to do the same steps. The commands may differ, but the steps are same. So I will go to environment variables, and let's go to path here. First of all, what I try to do is I just modify this Gradle home, right? Gradle home is the place where I store the current install Gradle, so Gradle 7.1.1, right? And in the path, what I do is I point to Gradle home /bin. Okay, all right, done. I also see some system variables, so I will remove this as well. This you don't need to do. I'm going to do this because this is going to cause a problem. Okay, Gradle home, and I will delete this. So we should have a Gradle home defined here. Okay, if I go to my command line and if I just press set, you can see somewhere that Gradle home is defined. Gradle home is the our Gradle download directory. Okay, I think I did not update it correctly. I will do it again. Gradle home. Okay, I did update, so I think I have to open a new shell. Let's open new command prompt. Set. So you can see Gradle home is pointing to Gradle 711, and in my path, I added the Gradle home path, right? So you have Gradle home /bin. Okay, if I say Gradle, Gradle version, I see that Gradle version 711 is installed, right? One more thing that you should know is Gradle requires Java to run. So Gradle itself is written in Java. So it needs Java or at least some JRE to run 1.8 or above. Okay, so Java should be installed. Java is installed on my machine. So we should be good. All right, and your Gradle is now installed. Okay, now let's create a Gradle project. So let's go to D drive, and in this D drive, so let's go to D. This is where all my training files are. Just give me 1 sec.
Thanks for watching. Want to study further? Join our training programs today.